Alrighty, today we will start section 12.5, volumes of pyramids and cones. Yesterday we did volumes of prisms and cylinders. So to refresh our memory, a volume of a cube, we could either do length times width times height, or B times H. Remember, B is the area of the base. Okay, remember this is a cube, so its base could be any of the faces really. But we know that all the sides, the length, width, and height are all the same. So my volume is going to be 5 times 5 times 5, which is 125 units cubed. Okay, now if I fit a pyramid inside here, it's actually going to be a third of the volume of a cube. So the volume formula for a pyramid is 1/3 area of the base times the height. Alright? So we take 1/3, we know the area of the base is 25, the height is 5. A third of 125 is 41.6 repeating units cubed. Okay, and that is the volume of this pyramid right here. Okay, if you'd like to take some time to fill out this chart, go ahead and do so now. Prism, P times H. Remember, P stands for the perimeter of the base. And it is just for the lateral area. Okay, surface area, lateral area, plus 2B. And our volume is B times H. And remember, B is the area of the base. And H is the height. Okay, so for pyramid, our lateral area is 1/2 P times L. L is the slant height. Okay, so we're going to take the lateral area and just add a base to it, not two bases, because the pyramid only has one base. Okay, so the volume for a pyramid is 1/3 area of the base times the height. Okay, moving into cylinders and cones. Cylinder lateral area is 2 pi r, which is the circumference, times the height. Okay, and we're going to take the lateral area and we're going to add 2 pi r squared, because the circle makes up the top and the bottom. For the volume, it's base times height, which is pi r squared times the height. Remember, base for a cylinder is a circle. And for our cone, we have a lateral area of pi r L. Remember, L is again the slant height. For surface area, we take the lateral area and just add pi r squared, because the cone only has one base, it's a circle. Okay, volume is very similar to a pyramid in that we're going to take 1/3 of pi r squared times the height. Okay, it's the same formula as this one, but we're going to take 1/3 of it because it's a cone, divided by 3. Sphere's lateral area is the same as its surface area. Do red. So that's 4 pi r squared. And then volume, 4/3, 4/3 pi r cubed. Okay, remember this is going to be units cubed. And surface area is units squared. Alright, let's see an example of the volume of a pyramid. Great Pyramid of Giza was built around 2450 BC, took more than 30 years to build. Okay, this is actually one of the 7 wonders of the world. Here's a picture, if you were curious. It's not made up. So more than 2 million large stones, weigh within 1 to 2 kilograms, each were used. Base of the pyramid is a square. So try to draw kind of like a rhombus. We're going to say it's a square, but it's a 3D shape. And connect all the vertices together. Okay. If you were to walk completely around the base, it would be a distance of 900 meters. Okay, what that means is the perimeter is going to be 900 meters. Okay, the height of the pyramid is 148 meters. So when we talk about height, we're not talking about slant height here unless it specifically says slant height. The height is going to be 148 meters. Okay, So if we want volume of a pyramid is 1/3 base times height. Remember, B is the area of the base. Okay, now my base is not 900. I'm going to figure out each side by taking 900 divided by 4, which is 225. Okay, so now each side is 225 units. Okay, it is a square, so to find the area of a square, I'm going to take 225 squared. $50,625. So 1/3 B is going to be the area of the square. 50,625, and height they give us in the problem 148. Okay, if you calculate that out, we get 2,497,500, and I believe we're in meters cubed, and that is the volume of the pyramid in cubic meters. Okay, let's try another one with a hexagonal base. Pyramid has a base that's a regular hexagon. Okay, so try to your best, draw a hexagon. We know that each side is 8. And it comes to a point because it's a pyramid. Okay, remember the volume of a hexagon, the area of a hexagon is 1/2 A times P, so we have to find the apothem in this case. Okay, so we just did an example like this in the homework. Okay, this is going to be a 30, 60, 90 triangle. Half of 8 is 4. Okay, remember the 30 degrees goes here, 60 is here. So our apothem is 4√3. Okay, so area of this space is going to be 1/2 4√3 times the perimeter. Perimeter is 4 times 8, 6 times 8, 48. Okay, so our base is going to be 96√3. Okay, that's our area of the base. Okay, remember the volume formula is 1/3 area of the base times the height. And we have a pyramid is set 12 inches tall. So I'm going to go ahead and draw in the height. Okay, this is 12 inches tall. So using my formula, go ahead and plug everything in. 1/3, 96√3 times 12. So we end up getting 384 inches cubed to their volume. Okay, in this one we have another pyramid. The pyramid has a square base with a diagonal of 18. Okay, so they are talking about the base has a diagonal of 18. Okay, and we know it's a square. So right away you should think 45, 45, 90. Okay, 18 is going to be x√2. This is x. If I divide by √2 and I multiply by √2, I'm going to get 9√2. So now I have each side is 9√2 of my square base. Okay, now I can get the area of the base. I still need the height. They tell us that the lateral edge measures 15. So this is the lateral edge. This is going to be 15 units. Okay, let's think about how I can get the height. Well, if I go ahead and draw in the height, I know that's 90 degrees. Hopefully you can pull out that right triangle right here. And that's going to be, I know this is 15. Remember, it's a square. Diagonals are bisected in a square, so the bottom is 9. So we have a 9, 12, 15 triangle. Okay, which is a 3, 4, 5 triangle. So now I know my height is 12. Okay, remember for volume of a pyramid, I need 1/3 area of the base times the height. So take 1/3. Area of the base here is going to be 9√2 squared. Okay. Times the height, which is 12. So 9√2 squared, 9 squared 81, √2 squared is 2. So we have 1/3, 81 times 2 times 12. Okay, so we get 648, and that is units cubed. And that's our volume. Okay, moving on. Last two examples. Okay, moving into cones. We want to find the volume of the upper cone. Okay, solid above the cross section. So I'm looking for this cone up here first. So to find that, I'm going to do a volume of 1/3. It's a cone, so it's 1/3 of pi r squared times the height, 1/3 of the cylinder. Okay, so we just take 1/3, just plug everything in, 6 squared, and the height is 4. So, which equals 48 pi, and that is units cubed, because we're doing volume. Okay, next part, find x in the volume of the frustum. The frustum is this part down here, so it's like a cone that's chopped off by another cone. Okay, this is a frustum. So before we find x, we're going to use ratios. Okay, we're going to say 4/6. And be careful here, we can't say 8 to x because 8 is not the whole side. Okay, the whole side here is going to be 12. So 4/6 and 12/x. We're going to cross multiply. 4x equals 72. Divided by 4. X equals 18. Okay, so now I can get the volume of the frustum. What I want to do here is take the volume of the large cone and subtract the volume of the small cone. What I just found, the 48 pi. Okay, so now that I know the radius, I can get the volume of the big cone. Volume of the big cone is going to be 1/3 pi r squared. So we have 18 squared times the height. Now careful here, the height is not 8, the height is 12. Okay? Okay, so the volume of the big cone is 1,296 pi. Okay, we already know the small cone, which is 48. The small cone is 48 pi. I subtract the 2, I'm going to get the volume of the frustum, which is 1,248. That's my final answer. Alright, last one. We have a cube that has a surface area of 54 square centimeters. Okay, so this is the total surface area. Okay, we don't know any of the sides, and we want to find the volume of the cube. Okay, so I'm going to say I don't know this side, don't know this side. But I know that there are 6 sides. Okay, so since I know there's 6 faces, I can take 54 divided by 6. Okay, because I know the surface area is 6 faces added up all together. There are 6 faces total here. 54 divided by 6 is 8. And 8 has to be the area of one of the bases. So 8 equals x squared. 4 roots. Each side is going to be 4. 4 equals x. Okay, so now I can go ahead and plug it in for the volume of the cube. Volume of the cube, length times width times height. So we have 4 times 4 times 4. Alright, I just realized I messed up. 54 divided by 6 is obviously 9. Square root of 9 is 3, so volume is 27 units squared. try the next one and I'll put the answer in a minute. The answer is 3 root 3.